All right, this is the data you'll need for the Molar Hydrate Lab. So hydrate just means we have a compound that has some water loosely bound to it. When it has that water bound to it, it's called the hydrate. We're starting with the compound is copper sulfate or copper 2 sulfate with N moles of water attached, where N is the unknown number. So what we're trying to do in this lab is figure out how many moles of water are attached to the copper sulfate to figure out the degree of hydration. And first we're going to look at the experimental setup, and then we'll go over some of the calculations. This data should already be in Canvas, but I'll show you how we're going to collect the data as we move along. So for this experiment, we're going to be using our crucible here, which is, this is our crucible and our crucible cover. It looks like a little acorn. We're going to set up our Bunsen burner with our ring stand. We're going to have a ring, and then we're going to have our clay triangle sitting here. And the first thing we're going to do is put our crucible on the ring stand, and we're going to heat that crucible for 10 minutes. So we're heating the crucible to bring it to constant weight so that we know the weight is once it's been, any water or moisture that's in it is driven off. After we've heated that for 10 minutes, we're going to use our crucible tongs here like this to, first we're going to adjust our lid so our lid doesn't fall off. Then we're going to use our crucible tongs to lift this off, and then we would go weigh that. And that will be the weight of the crucible with nothing in it. And that'll be our starting point. Then what we're going to do is we're going to add about 2.5 grams of this copper sulfate that has an unknown degree of hydration to the crucible. So we pour that in there, and then we're going to come back put this on the balance and weigh the crucible now that it has the hydrate in it, as well as the weight of the crucible. And the difference between those two weights will give us the weight of the material in the crucible. So we have the mass of the crucible empty and the mass of the crucible with the hydrate in it. The difference will be the mass of how much hydrate is in there. The next thing we're going to do is heat this crucible up with the hydrate in it for about 15 minutes, and then we're going to let it cool and weigh it again. And we're heating it up to try to drive the water out, because that water is loosely bound. Then we're going to take the crucible off, weigh it again, and that would be the mass of the crucible plus the salt inside after the first heating. Then we're going to bring it back, set it up, heat it up for another 10 minutes, let it cool off and weigh it again, and get the mass of the crucible after the second heating. If those two numbers are relatively constant with each other, that means we've heated it enough to drive off all the water of hydration. If those two weighings differ substantially, then we would heat it again, because that would mean there's still some water bound to that material and we need to drive that water off. So that would be the data that we would collect for this experiment. And that data will already be on Canvas for you. But if you want to record it as part of this video, then the mass of the dry empty crucible was 31.5216 grams. After I added the hydrate to it and reweighed it again, the mass of the crucible plus the hydrate turned out to be 34.03580 grams. The difference will be the mass of how much hydrate is in there. After the first heating, our crucible with the solid ended up weighing 33.1317 grams. We heated it up for a second period of time and weighed it again. And now the crucible weighs 33.1307 grams. So it was only changed by 1/100 of a gram. So we can assume that we've driven off all the water. So with these 1, 2, 3, 4 numbers, you should be able to complete the remaining part of the lab. You're going to figure out the molar mass of the anhydrate. The anhydrate means without the water, so this would be the molar mass of just copper sulfate. The mass of the hydrate is the difference between these two numbers. Then the mass of solid remaining is, this is what the crucible weighed empty. This is what it weighed after we heated it. So all that's left inside of it is the solid remaining. So the difference will be the mass of the solid remaining. Then the mass of lost water would be the mass here minus the mass of the hydrate minus the solid remaining, because what was driven off was the water. So we'd take the mass of the hydrate, the mass of the solid remaining. The difference between those is how much water was driven off in the heating process. All right, so in the lab, all we can do is measure grams, right? But in this situation, we want to know moles, and so we need to know the relationship between grams and moles. So remember, from our mole map, to go from grams to moles, we divide by the molar mass. So from the previous data you collected, you know the grams of anhydrate, which means the grams of copper sulfate. That's after we've driven off the water. And then we know you're going to take that molar mass of anhydrate that you calculated at the top of the page, divide grams of anhydrate by molar mass of anhydrate, and that will give you moles of copper sulfate. We know how many grams of water we drove off. We know the molar mass of water. There's 18.02 grams in every 1 mole, so you're going to divide your grams of water by your molar mass of water, and that gives you moles of water. So the next thing you have to do is figure out the degree of hydration, which is that N that we had in that we started with. So what we're trying to do is determine what this N is, which is the degree of hydration. So if we take the moles of water that we calculated here and divide it by the moles of anhydrate, that gives us the ratio of water to copper sulfate. And let's say, for example, that we had 8 moles of water and we had 2 moles of copper sulfate. That ratio would be 4. Our degree of hydration would be 4. So the formula for the copper sulfate would be copper sulfate 4 H2Os. And that's what we're trying to do in this experiment, is find this number. This is just a made-up number. When you actually use the data I gave you, you should calculate some degree of hydration. So that should be everything you need to complete the lab.